Unleash the power.
Nuclear energy, the explosive power hidden inside every atom. What if I told you that inside everything around you, the chair you're sitting on, the air you're breathing, even your own body, is an incredible amount of hidden energy. Energy so powerful that a tiny piece of uranium no bigger than your thumb can produce as much energy as tons of coal.
Power for all.
Energy powerful enough to light entire cities. Power submarines for years without refueling. Send humans to Mars. And, sadly, create some of the most destructive weapons ever made. This is the story of nuclear energy, the explosive power hidden inside the atom. And it all begins with a question: what exactly is an atom?
What is it?
Chapter 1: The Invisible World.
Look closer.
The beginning.
For thousands of years, people wondered what everything was made of.
To the core.
Around 2,400 years ago, a Greek philosopher named Democritus imagined that if you kept breaking matter into smaller and smaller pieces, eventually you would reach something that could not be divided anymore.
The indivisible.
He called these tiny particles atomos, meaning indivisible.
Still hidden.
But nobody could prove atoms existed, not for over 2,000 years.
The first theory.
Then in 1803, English scientist John Dalton proposed the first modern atomic theory.
The whole universe.
Scientists finally began to believe that everything in the universe was made from tiny atoms. But what did an atom look like? Nobody knew.
What is it?
The core.
Chapter 2: Discovering the heart of the atom. In 1909, a scientist from New Zealand named Ernest Rutherford performed an experiment that shocked the scientific world.
It bounced back.
He fired tiny particles at a thin sheet of gold. Most passed straight through, but a few bounced back.
It returned.
It was as if someone fired a cannonball at tissue paper and the cannonball came back. Rutherford realized something amazing.
The heart.
Atoms were mostly empty space. At their center was a tiny, incredibly dense nucleus, the heart of the atom. Later, scientists discovered that this nucleus contained positively charged protons and neutral particles called neutrons. Around it raced tiny electrons.
The secret.
For the first time, humanity had discovered the structure of matter itself. But nobody yet knew the secret power hidden inside. Chapter 3: Einstein's Clue.
Eureka! A clue! It's all.
In 1905, another scientist made a discovery that would change history forever. His name was Albert Einstein.
Everything is energy.
He developed a famous equation, E equals mc squared.
Mass and energy are connected.
This simple equation revealed something astonishing. Matter and energy are connected.
Mass could be converted to energy.
Even a tiny amount of mass could be converted into an enormous amount of energy. At the time, it sounded impossible. But Einstein had unknowingly provided the key to unlocking nuclear power. The question was, how could scientists release that energy?
The world changes.
Chapter 4: The Discovery that changed the world.
Answer arrived.
The answer arrived in 1938. German scientists Otto Hahn and Fritz Strassmann were experimenting with uranium.
Lisa helped.
Their colleague, Austrian physicist Lise Meitner, helped explain the results.
Atomic nucleus broken apart.
Something extraordinary had happened. The uranium atom had split.
Was the mass really gone?
For the first time in history, humans had broken apart an atomic nucleus. The process became known as nuclear fission.
Mass transformed into energy.
As the atom split, some of its mass disappeared, but it wasn't really gone.
Discovery of hidden energy.
It had been transformed into energy, exactly as Einstein's equation predicted.
Energy unlocked.
Humanity had discovered how to unlock the energy hidden inside matter itself.
Chain reaction.
Chapter 5: The Chain Reaction.
Energy released.
One split atom releases energy, but that's not enough to power a city. The real magic happens when one split atom causes another atom to split, and another, like a line of falling dominoes. This is called a chain reaction. When a uranium-235 atom splits, it releases neutrons. These neutrons strike nearby uranium atoms. Those atoms split too. Each split releases more neutrons. The reaction grows rapidly.
Controlled electricity. Uncontrolled explosion.
If controlled carefully, it creates electricity. If uncontrolled, it can create an explosion.
Control is important.
The same scientific principle can lead to either a power plant or a bomb. Everything depends on control. Chapter 6: The First Nuclear Reactor.
It's working! Fear.
The world was now in the middle of World War II. Scientists feared Nazi Germany might develop nuclear weapons first.
Understanding nuclear fission.
A team led by Italian physicist Enrico Fermi raced to understand nuclear fission. On December 2, 1942, beneath a football stadium at the University of Chicago, they achieved something never done before: the world's first controlled nuclear chain reaction.
Reactor born!
Humanity had entered the atomic age. The first nuclear reactor was born.
The power.
Chapter 7: The Atomic Bomb. Unfortunately, one of the first uses of nuclear technology was not peaceful.
The first atomic bomb.
Scientists working on the Manhattan Project developed the first atomic bombs. In August 1945, 2 bombs were dropped on Hiroshima and Nagasaki in Japan. The destruction was devastating. Hundreds of thousands of lives were affected. The world suddenly realized both the incredible power and terrible danger of nuclear energy. It remains one of the most important lessons in human history.
Use responsibly.
Great scientific power must be used responsibly.
Atoms for peace.
Chapter 8: Atoms for Peace.
Peaceful use.
After the war, scientists searched for peaceful uses of nuclear technology. In 1954, the world's first nuclear power station began supplying electricity in Obninsk, Russia. Soon many countries followed. Instead of producing explosions, reactors generated electricity. Today, nuclear power supplies a significant portion of the world's electricity, and unlike coal and oil, nuclear power plants produce very little carbon dioxide during operation. This makes them an important tool in the fight against climate change. Chapter 9: Nuclear Energy All Around Us.
Surprising ways of help.
Most people think nuclear technology only means power plants, but it helps us in many surprising ways.
Detect and treat.
Medicine. Doctors use radioactive materials to detect diseases and treat cancer.
Preserve food.
Food. Radiation can help preserve food and kill harmful bacteria. Agriculture. Scientists develop stronger crops using nuclear techniques.
Stronger crops.
Nuclear batteries.
Space. NASA uses nuclear batteries to power spacecraft exploring distant worlds. Industry. Engineers inspect pipelines, bridges, and aircraft using nuclear technology.
Nuclear science.
Without nuclear science, many modern technologies would not exist. Chapter 10: Nuclear Giants of the Ocean. In 1954, the USS Nautilus became the world's first nuclear-powered submarine. Unlike conventional submarines, it could stay underwater for months.
Nuclear ships and icebreakers.
Nuclear-powered ships and icebreakers soon followed.
Years to refuel.
Even today, many naval vessels use nuclear reactors because they can operate for years without refueling.
Infinite energy.
Chapter 11: The Dream of Nuclear Fusion.
Fission.
Everything we've discussed so far uses nuclear fission, splitting atoms apart.
Fusion.
But nature has another method: fusion. Instead of breaking atoms, fusion combines them. This is how the sun shines. Every second, the sun fuses millions of tons of hydrogen into helium. The process releases enormous amounts of energy.
Let's recreate.
Scientists hope to recreate this on Earth.
It's clean.
If successful, fusion could provide clean energy,
No waste.
very little long-lived waste,
Abundance.
fuel from abundant sources, and nearly limitless electricity.
Transform
Projects around the world are
civilization.
racing toward this goal. Many believe fusion could transform civilization during this century.
To the stars.
Chapter 12: Nuclear Rockets and the Future.
Lots of fuel.
What about space travel? Traditional rockets carry huge amounts of fuel. The farther they travel, the harder the journey becomes. Nuclear propulsion could change that.
Reduce time.
Scientists are developing nuclear thermal rockets that could dramatically reduce travel times to Mars.
Far beyond.
Even more ambitious concepts could someday take humans far beyond our solar system. In the 1950s, Project Orion proposed a giant spacecraft powered by controlled nuclear explosions. It sounds like science fiction, yet many scientists considered it technically possible.
Interplanetary.
One day nuclear technology may help humanity become an interplanetary species. Fun facts. A uranium fuel pellet the size of a fingertip can contain as much energy as roughly a ton of coal.
It's a reactor.
The sun is actually a gigantic natural fusion reactor.
Beyond.
Nuclear-powered spacecraft have visited Jupiter, Saturn, Pluto, and beyond.
No refuels.
Some nuclear submarines can travel around the Earth several times without refueling.
Radioactive.
The smoke detectors in many homes use tiny amounts of radioactive material.
Incredible force.
Inside every atom lies a hidden universe of energy. For over a century, scientists have worked to understand this incredible force.
The nucleus.
From Rutherford discovering the nucleus,
Matter and energy.
to Einstein revealing the connection between matter and energy,
Unlocking.
to Meitner, Hahn, Strassmann, and Fermi unlocking nuclear fission.
Greatest power.
Humanity has learned how to tap one of nature's greatest powers. The story of nuclear energy is not just about science. It's a story of curiosity, discovery, responsibility, and the future of our civilization.
In the
Will
making.
nuclear fusion power our cities? Will nuclear rockets take us to Mars? Or even to the stars? Only time will tell. But one thing is certain. The power hidden inside the atom will continue shaping the future of humanity for generations to come.
Don't forget to hit the like button, subscribe by clicking the bell, and share this video. And I'll see you in the next one.